Okay, this problem concerns two different PDFs, and we want to confirm that it's a PDF and find the expected value as well as the variance. Okay, so to confirm that it's a PDF for the first part, to confirm it's a PDF, we just take the integral from 0 to 1 of 3 1 minus x squared dx. And there's several ways to do this. The simplest way, perhaps, is by just simply multiplying the blasted thing out. 3 minus 6x plus 3x squared dx. And then we get that this is equal to 3x minus 3x squared plus x cubed, evaluated from 1 to 0. Plugging in 1, we get 3 minus 3 plus 1. Plug in 0, we get simply 0. And so the integral is 1, and so that confirms that it is a PDF. Now this also could have been done with a U substitution. I'll let you think about that if you'd like to do it that way, but basically to show it's a PDF, we integrate it and find that the answer is 1. Next, let's figure out the expected value of x. The expected value of x is going to be the integral from 0 to 1 of the PDF times x. So I multiply by an extra x inside. To do this integral, again, let's multiply out. So it's going to look an awful lot like what we had here, except there's an extra x involved. 3x minus 6x squared plus 3x cubed dx. Okay, we do the integral, and we get 3 halves x squared minus 2x cubed plus 3/4 x the fourth, evaluated from 1 to 0. So plugging in, we get 3 halves minus 2 plus 3/4. Plugging in 0 is fairly straightforward. And then doing the arithmetic, we get 3 halves minus 2 is negative a half, plus 3/4 is 1/4. And so the expected value of this random variable is 1/4. Lastly, to find the variance, the first thing we do is figure out the expected value of x squared. So that'll be integral from 0 to 1 of 3x squared, 1 minus x squared dx. So integral from 0 to 1 of 3x squared minus 2x cubed plus 3x the fourth dx. So take the original PDF and then multiply it by x squared. Doing the integral, we get x cubed minus 6/4 x the fourth plus 3/5 x the fifth, evaluated from 1 to 0. Okay, and then plugging in, we get 1 minus 3 halves plus 3/5 minus 0 again. And so that works out to be simply, let's see, so we have 1/10, I believe, because this is 1 minus 3 halves is minus 0.5, 3/5 is 0.6, so 0.6 minus 0.5 is 0.1. So finally, to find the variance of x, the question asks to find the variance of x. The variance of x is equal to the expected value of x squared minus the mean squared. So that's 1/10 minus 1/16. So I square 1/4 to get 1/16. And then get the least common denominator, works out to be 80. So that's 5/80 minus, 8/80 minus 5/80, which works out to be 3/80. And so that's the variance. The question did not ask for this, but the standard deviation of x would then be the square root of the variance, square root of 3/80, which is approximately 0.19364. And so that would be the mean and the variance, and just for fun, the standard deviation for this random variable. Now for part 2 of this problem, we find the do the same kind of calculation for this piecewise defined function, where it's between 0 and 1, the value is 3/4. Between 2 and 3, the value is 1/4, and at 0 otherwise. So before doing any calculations, let me just kind of draw the picture just to see how this looks like. So 1/4, 2/4, 3/4, 1, 2, 3. So the random variable looks like, the PDF looks like this. It is piecewise defined. Okay, so to confirm it's a PDF, I have to show that the area under the curve is 1. Now, we can just look at it and see that the area under the curve is 1. The area of this rectangle is 3/4. The area of this rectangle is 1/4. And so the total area under the curve is going to be 1. To do this more mathematically, the integral from 0 to 3 of f of x dx, and I shouldn't say more mathematically, I should say with calculus, to do this in the same way that we did for the first part. The integral from 0 to 3, well, from 0 to 1, the function is defined to be 3/4. And from 2 to 3, the function is defined to be 1/4. So because it's piecewise defined, this integral splits into two parts. Okay, so that's 3/4 x evaluated from 1 to 0, plus 1/4 x evaluated from 1 to 0, sorry, from 3 to 2, pardon me. And so this is 3/4 times 1 minus 0, plus 1/4 times 3 minus 2. And not surprisingly, that's the exact same thing as we saw over here. The height of this rectangle divided by its width, plus the height of this rectangle times its width. And so that's equal to 1. Okay, so that confirms that it's a PDF. The expected value of x is the integral from 0 to 3 of x times f of x dx. And we will compute this in exactly the same way. Integral from 0 to 1 of 3/4 x dx, plus the integral from 2 to 3 of 1/4 x dx. Okay, so doing the integral, we find this is equal to 3/8 x squared, evaluated from 1 to 0, plus 1/8 x squared, evaluated from 3 to 2. So that is 3/8 times 1 minus 0, plus 1/8 times, plugging in 3 and 2, we get 3 squared minus 2 squared. And so we get 3/8 plus 5/8, and that works out to be 1. So the mean of the distribution is 1, that this thing balances right here. If I were to imagine that this is a plate, and that's a plate, and this is kind of like a seesaw, I would put the fulcrum right here, and the weight would balance. Okay, next, to find the variance, the first thing we do to find the variance is find the expected value of x squared. So that's integral from 0 to 3 of x squared f of x dx. So that's integral from 0 to 1 of 3/4 x squared dx, plus the integral from 2 to 3 of 1/4 x squared dx. So integrating, we get that this is x over 3 divided by 4 from 1 to 0. And this one is 1/12 x cubed from 3 to 2. So this works out to be 1/4 times 1 minus 0 plus 1/12 times 3 cubed minus 2 cubed. And if I did the arithmetic correctly, I believe this is equal to 11 over 6. So now we are in position to find the variance and the standard deviation. The variance of x is equal to 11 over 6 minus 1 squared, which is 5/6. And therefore, the problem didn't ask for this, but it's an easy next step. The standard deviation of x would therefore be the square root of 5/6. So this problem required, part 2 of this problem required a little bit of extra thought because the function was piecewise defined. The integrals here, when I computed the expected value of x and the expected value of x squared, had to be split into two parts.